Hi there, I'm Mr. Vona, and we are going to be doing some geometry problems, getting ready for our GED, high set, etc. And we are basically doing some surface area and volume problems. So our objective for this video is that students will be able to calculate the surface area and the volume of cones. All right, so basically we're just doing different shapes that you might encounter. All right, so I have a cone drawn here. This is my formula for the surface area, and this is my formula for the volume. Again, in the description below on this video, you'll see a link that will take you to the notes for this lesson, as well as a formula sheet for all these different shapes. So check that out. All right, so let's get right into it. We have this cone, and the problem states that Caltrans they're a transportation in California. They want to produce like 50 cones, I believe. Yeah, 50 cones. Okay, and they want to spray paint the cone part of the cone orange, and they want to paint the bottom, the circular part, black. All right, and they're going to make 50 of these. All right, so here's the question: how many square centimeters need to be painted orange for 50 cones? So how many square centimeters for 50 cones? Okay. All right, so here's something very important. The orange part. This is the orange part, right? So this part. This is very important. On this formula, the surface area, that's what we're going to figure out. We're going to find the surface area because we're going to be painting the surface of the cone. It's very important that you understand what these two mean here. Okay, I have pi rs plus pi r squared. Okay, so pi rs is the cone part of the surface. All right? Pi r squared, if you remember, is the formula for the area of a circle. All right, that's going to be the circular area, the bottom area. Okay? That's the circle, or the bottom. Okay, that's important on problems like these because we're painting the cone orange, but we're painting the bottom black. And so the first question is, hey, how much square centimeters am I going to have to paint orange? Okay, so that means I need to figure out just this part, the pi rs. All right, so let's go ahead and take a look. So surface area equals pi rs, not pi r squared, pi rs plus pi r squared. But again, we're only going to be painting the orange, this cone part. So we're going to go ahead and ignore that part, the circular part. Okay, so let's go ahead and substitute in our numbers. All right, so pi is just a constant. It's about 3.14. Okay, R stands for radius. Okay, what's my radius of this cone? Well, the diameter of this cone is 30 centimeters. And remember, the radius is just half of the diameter. So the radius would be 15 centimeters. 15 centimeters. All right. Now, what about S? What is S? S is the slant height. The slant height. What is the slant height of this? Well, it's not given, is it? So that means we're going to have to figure it out. Well, take a look at this. What I'm going to do with this cone is I'm going to make a right triangle. basically I'm going to cut this cone in half, right down the middle. And so that's going to leave me basically two right triangles, but I'm just going to draw the right-hand side. Okay? So this is a right angle. Okay, what's my height here? My height is 61 centimeters. Well, and I got a bad pin here, don't I? 61 centimeters. I'm just going to say 61. Okay, and do I know my base? Well, my base, is just half of 30, right? My base is the radius. My base is going to be 15. All right, I'm going to chuck that pin. Okay, so I have a right triangle, and I know the two legs of my triangle. Do you know how to find the slant height? I'm just going to call that S. Well, if you remember, we learned how to use the Pythagorean theorem. The Pythagorean theorem states that a squared plus b squared equals c squared. Okay, so this is like a, and this is b, and this is c. All right, so I'll just draw a little picture over here. A, B, C. Okay, for any right triangle, C is always the hypotenuse. This is my hypotenuse. Okay, so what's A going to be? Well, A is a 61. So I'm going to put 61 squared plus B. B is this length here, so that's 15. I'm going to square that. Equals C squared. In this case it's S, isn't it? I don't like the letter S because it looks so much like a 5, but I'm just going to make it real curvy. Okay, so 61 squared. Okay, what is 61 squared? I don't know what 61 squared is, so I have my calculator. It's just 61 times 61, all right, which is 3,721. So I got 3,721 plus 15 squared. Is that 300? Not sure. Nope, 225. 225 equals S squared. All right. Now I just got to add these two numbers up. 3721 plus 225. 3721. It's 3946. So I get 3946 equals S squared. All right. Now, I need to solve for S, don't I? The problem is I have that exponent. Do you remember what the inverse of a square is? Or something raised to the second power? You got it, it's a square root. All right, so if I took the square root of that, and I have to do the same to the left side, the square root of S squared, if you remember, is just S. So S equals the square root of 3946, and this is where a calculator earns its money. So the square root of that is about 62.8. So instead of an equal sign, that squiggly equal sign means approximately equal to. Did I say 62.8? Yes, I did. 62.8 what? Well, we're talking about centimeters, aren't we? Let's check that for reasonableness. If the height is 61, does it make sense that this would be just a little bit more? Yeah, the slant height's going to be a little bit more than the actual height. All right, because it forms basically the hypotenuse. All right, so My slant height is 62.8, so I had to do some work for that. All right. So times 62.8. All right. Now I can go ahead and find my surface area of the cone part of my cone. Let's see. So I got 62.8. 62.8 times 15 times pi is, it's going to be approximately 2,959, something like that. I'm probably getting a rounding error there. 2,959, and that's square centimeters. Square centimeters. Okay, so that is for one cone, right? Well, that's a lot. It's a lot of square centimeters. Okay, so, but they're designing, they're going to be painting 50 cones. So what I need to do is I just simply need to multiply this by 50, right? Because we're doing 50 cones. So what would that be? Times 50, wow. So the total surface area for 50 cones, and we'll do one cone, is 147,969, give or take, and that's in square centimeters. All right? So again, I got my formula. I had to get rid of this section because I'm not painting the bottom orange, I'm painting the bottom black. And I had to figure out my slant height by using Pythagorean theorem. And then I could just do all that multiplication and multiply by 50 to get for 50 cones. All right, so that was part one of this problem. All right, but we're not finished painting these cones, are we? We still have to paint the bottom black. All right, so let's do that. How much black paint are we gonna need? Let's see. All right, so how many for 50 cones for the bottom? All right, for bottom circle. Okay, so I have my surface area formula here. So I have surface area equals pi rs plus pi r squared. And in this situation, I don't need this part of my formula because I'm only painting the circle. All right, so I can get rid of that part. All right, so it's important that you understand, what this means. All right, let's figure this out. In fact, why don't you pause this video and see if you can find the surface area of just the circle. All right, are you back? All right, so let's go ahead. The radius is 15, and I got to square that. All right, and we already know that 15 squared was what, 225? So 225 pi. If they say, hey, leave it in terms of pi, there's your answer. If they say, hey, approximate it to the nearest whatever decimal, well, we got to use our calculator here, right? What's 225 times pi? Well, it's about 706.9. So surface area is approximately, what did I say? I have a short-term memory here. 706, how about we just say about 707, if we're rounding this to the nearest whole number, all right? All right, it's really like 706.9, but close enough, right? Besides, this is for Caltrans, it's the government, it's close enough for government work. So there's our surface area for one cone for the bottom. But again, we're making 50 cones. So we're going to have to multiply this. Well, let's do this with black because we're going to paint these things black. We got to multiply this by 50. All right, so what's 707 times 50? Let's see, 707 times 50 is 35,000. Get the pin out here. 35,350. 35,350. So that's surface area for 50 of them. And that is in square centimeters. All right, so really we should not have boxed that. Okay, it's very important that you read the question. After you get a number, read the question. So I can almost guarantee you that on the test, 707 is going to be one of the answers. Okay, because they're going to count on you being careless and not remembering that this is for 50 cones, not for one cone. So anytime you get a number, go back. What's the question? Oh, for 50 cones. Oh, okay, got to multiply by 50. All right, so just be careful. Okay, now after they get done painting these cones, they're going to need to ship these to the site. All right, so they want to know, okay, how much space are these 50 cones going to take up on our truck? How much space will they take up? Well, what's that a question of? Is that a question of surface area? That's a question of volume. How much volume are these 50 cones going to take up? Well, in order to do that, we need to use our volume formula. So let's just go ahead and start that right here. All right, so volume is 1/3 pi r squared h. Well, Mr. Von, why did you write the formula down again? You already have it right there. Well, because I want to learn the formula. Okay? If you want to learn formulas, you write them down every single time. All right? So let's see what we got here. Can we find the volume? Do we know R? Yeah, it's 15. Do we know H? Yeah, it was given, 61. So this one's easier, isn't it? So we got volume equals 1/3 pi R, which is 15. And we got to square that. H, which is 61. All right, and now our calculator is going to earn its money. Let's figure this out here. In fact, see if you can go ahead and pause this video, see if you can get it. All right, welcome back. What do we got here? We got 15 squared. We got to do that first. All right, exponents come first. Then you can multiply however you want. I'm going to multiply by 61 times 61. Now I'm going to multiply that by pi. Now I'm going to multiply that by 1/3. Another way of doing that is just simply by dividing by 3. You see how the 3 is in the denominator? All right? So I'm just going to divide by 3. And I get 14,300. I'm just going to round to the nearest whole number. 373. Okay, and that is in cubic centimeters, cc's. Okay, now be very careful though. What's the question asking? The question is asking, how much space in cubic centimeters will 50 cones take up? Ah, this was only volume for one cone. All right, so the volume for 50 cones needs to be what? Multiply that by 50. 14,373 times 50. That's going to be like 71. 718,650 cubic centimeters. And all right, so that's how much space it's going to take up in cubic centimeters. Pretty cool, huh? So one of the beauties of this video is it showed you that, hey, you got to be mindful when you're doing surface area or any of these formulas. You got to know what these two terms mean. This is the cone part, this is the circular part. Okay, you got to be mindful that you got to remember to answer the question properly. Okay? All right, so I hope this video was helpful. I hope some of it at least made sense. And make sure you subscribe to my channel and you can get alerted whenever I make new videos. So, until next time, may God richly bless you, my friend.